Here we have another integration by parts example problem. And this example problem is really interesting because it shows how setting up our integration by parts and selecting which terms we want for our u and dv is really important for determining if we're able to integrate the example. So here we have the integral of ln of x dx, and really we have two options when determining our u and dv values. We can either select ln of x to be our u, or we can select ln of x to be our dv. So we can go ahead and look at two different options where for option number one, we're going to select ln of x for our u term, and for option two, we're going to select 1 as our u term, or just a constant. So here we have it. With that, for option one, we can go ahead and write dv as dx, and we can take the derivative of u to get du, or 1 over x dx, and then we can get v by integrating dx, which will give us x. And in option 2, we'll take the derivative of u, or 1, and get 0. And for v, we'll take the integral of ln of x. But wait a second, we can see that this integral is really just what we started out with. So you can see this integral of ln of x is the same as the v term. So selecting option number 2 will basically put us in a loop to where we will never be able to produce a solution. So we'll go ahead and move forward with option number 1, where we'll have u, v, so the first part in our integration by parts formula to be ln of x multiplied by x, and then we'll subtract it by v du, or x, 1 over x dx. And so now when we look at this, we can go ahead and simplify this to just 1. And so we have something that is integrable, and so we can go ahead and do that, where we'll get x ln of x for the first portion minus the integral of 1, which is x, and then we'll add our constant. So here we have it, our solution to this example problem.